Good afternoon, Mr. Jerry, sir. Am I audible to you?
Hi, good afternoon.
How are you? Can you hear me?
Yeah, I can hear you.
Great. In which city are you?
Do you hear me?
You are right now in which city?
Can you see me?
Okay. Thank you for joining the team.
Sure, thanks.
We are waiting for some participants to join.
Okay.
So we will exactly start at 2:45. I talked to Mr. Vikas Asavat sir also. So he will be also joining.
Sure. Sure. 喂，哎，Daniel，是。
Piyush, will you please present?
Yes, sir.
Organizing team, are you ready?
Yep.
Participants, yeah, few participants will be joining in few minutes, but we are now at 2:45, so I think we can start now.
Yes, sir.
Good afternoon, and I welcome you all for this today's session, which is a special address on recent innovation related to medical services by Dr. Chieh-Hsiao, who is known by a name Jaya also. Something about Sir. Sir has completed his medical degree from the Kaohsiung Medical University, PhD degree from the Institute of Biomedical Engineering. He is a director, Department of Urology, China Medical University, Beigang Hospital. He is a visiting scholar in Medical School of Stanford University, Fellowship of Stanford Taiwan Medical Program. He is a Chief Executive Officer of Brain Navy Biotechnology Co. Limited, Chief Medical Officer and founder of iXensor Incorporated. Dr. Chen has backgrounds of medicine and biomedical engineering. In 2012, Dr. Chen was selected into the STB program and was sent to the Stanford University to learn the startups in the Silicon Valley. During the period, Dr. Chen and the other two STB fellows, Alan and Carson, start up the company iXensor Incorporated and was listed on Taiwan stock market in June 2019. Dr. Chen in 2014 established another startup company, Brain Navy Biotechnology Co. Limited, and became the CEO. Brain Navy focuses on innovative navigation systems of brain surgery. Brain Navy was also announced one of the winners of National Innovation Award in 2017, 2019, and 2020. NioTrack, the autopilot brain surgical systems, integrates advanced sensing technologies, AI, and robots to improve the accuracy, streamline surgical procedures, and decrease the learning curve for neurosurgeons. Another product, NSR, the nasal swab robot, helps medical staff during COVID-19 pandemic, is the first autonomous nasal swab robot that got authorized by a government. We are very happy to have you, sir, and I request you to start with the session.
Thank you for your introduction. Hi, thank you very much for your introduction. So can everybody see my screen?
Yes, sir.
Yeah. So I will introduce my company Brand Navi first, and then also the iSensor. For Brand Navi, is my second time for startups. So as the previous introduction, I myself is a medical doctor, a surgeon, and then went to Stanford for learn how to start up a company, and also I have already experiences about IPO in Taiwan. And so today I will introduce my journey for the innovation and the startups for to introduce a little bit to everybody. So if you have any question, you can also interrupt me and to discuss. For Brenavi Biotechnology, we are a company established in 24, started the project in 2014 and started the company in 2015. And we have about 30 employees right now, and we got already 20 patents received and another 31 on progress. Our vision is to make the surgery precise and make the life brighter. Um, our mission is to develop innovative navigation and robotic techniques for surgeons to improve the accuracy, streamline the surgical procedure, and reduce the learning curve of a neurosurgeon. We know that the medical market right now is very focused on robots, including a lot of big companies such like Stryker, Zimmer, Medtronic, and Johnson Johnson. They already have a lot of acquirement during the last 5 years. Such like Stryker had already merged Marco Surgical Group for 1.3 billion for a knee surgical robot, and Zimmer acquired Rosa Medtech for a spinal surgical robot for 110 million US dollars for the spinal surgeries. And we know that about 3 years ago, Medtronic merged Mazor Robots. Mazor Robot is a company in Israel, and the merge right at that year is about 1.7 billion US dollars. It's a very high amount of acquisition. However, 2 years ago, Johnson Johnson merged Iris Health, which is doing a robot for brachioscopy. And the merge price is 3.4 billion US dollar, another high level of merchant acquisition. So we know that for surgical robots, it is at a very hot point for merchant acquisition for large medical groups. And we, Brain Navi, provide a platform called Smart Platform that when you use this platform, we can do the registration and do the automation very fast. So with our technique, we have already have two products. One is NowTrack for the autopilot neurosurgical navigation robot for brain surgery. And another robot is for autonomous nasal swab robot to help the COVID-19 pandemic. Also, we have already developed another project with the National Chen University in Taiwan to develop a liver RFA project to ablate the small liver hepatic tumors. And also we are right now focusing on another 10 cancers for early treatment of the cancers. So this is the introduction of our first product, the NowTrack. It's a brain surgical navigation robots. So the feature of the NowTrack is that we use a lot of automatic technique. So it can recognize the patient and find out the patient and do the mapping by itself. And we also can do the tool registration very easily in 30 seconds. And we provide the very fast and precise navigation technique. So to deliver the procedures very smoothly, and we use the CT and MRI for the medical doctors to do the planning. Also, we included the AI inside to help medical doctors do the planning and do the decision. This is the video showing our introduction of NowTrack. So you can see the slide that the blue bar is the planning, the plant pathway, and the white material is actually the tube. So we have already finished 10 cases of the clinical trial, 15 cases of clinical trial in one of the medical center in Taiwan, and the result was perfect. And we published the result in CNS 2019 in San Francisco. And with this technique, during the pandemic, we found that we can also help medical staff during the pandemic. We know that medical doctors are risking their life to help our people. And however, even we have the experience of SARS 17 years ago, still we are doing the same thing after 17 years. So we don't have enough PPE and we use only a mask, a plastic mask. However, that actually cannot stop the aerosol of COVID-19. So a lot of medical staff are right now getting sick. So we want to help medical doctors to prevent that. So we provide a solution that is the nasal swab robot. This is actually the first and only nasal swab robot that is authorized by a government right now. So we are actually in the very first and only one. So we want to help not only in Taiwan, but we want to help other countries. So if our friends in India, if you have some interesting about these robots, and please contact us. And this is actually how it works. So you have to put on a nasal clip, and during all the procedures that the robot can grab it, the swab by itself, and then enter your nasal by itself and find out the pathway of how to insert the nasal swab into your nasal pharynx area. So you can see that it will choose the angle by very personalized. So it won't go to other place. It will directly to your nasopharynx area, very precise and very gentle. So you can see during the whole process that actually the medical doctors and nurses are standing behind the protecting shield holder, shield stand. So it was totally separated from the patient. So it is very safe and easy to control. And we also provide a total solution that we combine with a mini PCR or antigen test. So we can provide the result from swabbing to the result within 25 minutes. So it can really help, especially in the pandemic, that timing is very important. So you have time to do some corresponding to the condition. So I think 25 minutes right now is the fastest total solution all around the world. And we have already finished the clinical trial in 3 hospitals, and we have already have some early adoption in several of the hospitals right now. So we are right now have about 3 hospitals already adopt our devices as their standard procedures. So we want to help the airlines, the tourist spots, and other companies to help them to do the large-scale testing, and we call it a zero contact solution. So all the process from the swabbing to the result can be all done in one of the trunk, such like our medical trunk that it combines with the nasal swab robots and a PCR machine inside. So all the things can be done within this trunk. So it is a zero contact to the medical staff. So it will be more safe for hospitals to use that. And besides the brain Navi, I also, such as my introduction before, I'm also the CMO of another company called iXensor. So this is sorry. So this company is the first company I established in 2012, that, which is already IPO in Taiwan. And what we are doing is for mobile medicine. So I think especially during the pandemic, we know that mobile health is a hot topic, and also during this pandemic. So what we want to do is actually we want to shrinkage the whole lab onto your hand. So a lab on your hand is actually the future of mobile health. And we know that about 10 years ago, if you want to see a doctor, you have to wait. There's no internet. We have to wait for the doctors and make the appointment there. And with 2G, so you can use cell phone to make an appointment by phone, but it's still not very convenient. And with 4G, actually, the health become wearable. So I think a lot of people can wear the iWatch on your hand or other kind of devices on your hand. However, it can only do some non-medical measurement for that. So it's not approved for a medical device, actually. However, since 2017, the things starting to change. First, the 5G comes, and another thing is that the FDA started to approve the medical procedures on your smartphone. So iXensor, my company iXensor is actually the first one that got a FDA approval for a measurement of a parameter on your smartphone, directly on your smartphone. So with this technique, we call it a pixel test. It is a FDA approved technique. We can do the glucose test on your smartphone. So it is directly connected with your sensors on your smartphone, such that we use the camera as a detector, and we use our strips as a test. So it can detect the color change of the test strips. So it is already approved in FDA, and based on this technique, we can change the bandwidth and we can change the colors of the light, so we can detect a lot of parameters.
Did you know that in vitro diagnostics can also be done on your smartphone? iXensor's globally exclusive PixoTest technology can turn your mobile devices into in vitro diagnostic medical devices. With our innovative test strips and Pixo Health app, you can measure, record, and upload your test readings to the cloud with just one click. This enables users to monitor their conditions of diabetes, cardiovascular diseases, women's health problems, or infectious diseases. The data can also be used for patients' self-management, medical professionals' analysis, or the government's appraisal of disease control policies. Meter-free, extensible platform, synchronization. PixoTest is constantly dedicated to the creation of the most efficient smart healthcare.
So with our technique, actually, we can combine with, we can collaborate with hospitals, doctors, and other companies together. So we provide a platform for them to build up their, so we provide a PixoTest platform to help other medical doctors other medical companies to develop a new diagnostic tools for them. So we have 3 pipelines. One is for the chronic disease management, one is for women health management, and another is for infection disease management. Such that for women health management, we know that in Taiwan, one in 7 couples are actually infertility. So in 2016, we know that the women getting their first babies become late and more late and late. So it's already more than 31 years old. So the timing for the intercourse is actually very important, because when you are getting old, it's difficult to get pregnant. So we have to measure, we have to check their time for ovulations. So we develop an ovulation test, and we already know that there's a lot of ovulation tests in the market. However, it's not actually very easy to read, and sometimes become confusing for the women who want to have the test. So we developed the Eveline test that combined with test strips and your own smartphones. We actually developed the app for the market, and more than 400 types of smartphone, including Androids and the iPhones, can already be used for Eveline ovulation test. And it is already in the market in Europe, in United States, and in some of the Asia companies. So with this technique, we got a good design award, the Baby Tech Award in CNS, and a lot of awards all around the world. So this technique can analyze and remind you when to take the test, and it can do a contact such that when you are having when you have a test that show you are going to ovulate within 24 hours, it will remind your husband to go home earlier, so you will get easier to get pregnant. And also we embedded some AI to do the prediction of your ovulation periods. So it is personalized the medicine. So it will be more precise and more easy to understand. So we have a lot of feedback from our clients, and actually the famous YouTuber in Taiwan got their baby with our technique. So Eveline is actually helping a lot of women, but it is actually a platform. It not only can check the ovulation, but also can check others. So we are developing the whole pipeline for women health, such like the LH or HCG or vitamin D or other biomarkers for mothers and for babies. And we have chronic disease management, and we know that in a lot of countries that the medical service is not so easy. They have to go for a long way, such that in United States or other countries, you have to travel a lot to go to the hospital, and then maybe you just have a very simple blood test. And then you have to go back again in 7 days to have the reports. It's not very efficient, and it takes a week to do that. But with our technique, the Pixel Test POCT module, so it is portable, efficient, and easy to management. So with this technique, you can do the test and have the result in 3 minutes with only one blood drops. And with our technique, it can synchronize the data to the cloud, so you can have the result very easy. And besides, you can also bring the machine to bedside. So you can bring it to home. If you want to do the home visit, you can use the machine with you. So you don't have to go to the hospital either. So it's more convenient for use. And right now we already have lipid panels and HbA1c, and heart disease is ongoing, and cancer detection is ongoing. So actually, that's what I said. A lab on your hand is actually the future of mobile health. So with this technique, I think it can change a lot. Another big thing is that for infection disease management, we know that we know that we are in the pandemic right now, all around the world. For the disease outbreak, actually, it is sometimes it's not so convenient. Such that when you have a test, you have to do the so we provide a solution to the government that when you have the test, such like the antigen test or the antibody test, when you're doing the test, it can synchronize the data to the CDC's cloud in in seconds. So the CDC will receive the result very soon. So we already doing this study with dengue fever and Zika virus before in 2017, and right now we are developing the antigen test for COVID-19 right now to help the pandemic. We will announce the product very soon. I think within a quarter we will announce the product with our technique to provide a result for antigen test, and then synchronize to the government. And we know that not only the test result is important, but also including some informations such like time, locations, climate data, and the environments, and other such like the travelers and flights. So these data combined together can predict where and when to outbreak the disease. So these data is very important. However, these data can be found where? Can be found in your smartphone. So if you have the test on your smartphone with our platform, we not only provide a positive or negative result, we can also provide these data to the government to help to control the pandemic. So it will be very easy, just one click, and then put your such like your antigen test or antibody test, and then with one click, all the data can be finished. So I think in the past time, we have a telephone, and then we switch to cell phone, so it become a more easier to communicate. But right now we change to smartphone era. So smartphone can do a lot, not only for money, not only for buying things, for shopping, for photograph. In the future, it will become the hub of your health. So it can be, we can collaborate with other companies to doing that. So if you are interested, you can also contact me for further collaborations. So this is our iXensor's mission and visions. We want to facilitate the data-driven healthcare with instant medical tests and streamline the data synchronizations. We want to make the quality healthcare accessible and timely. So this is our co-founders. And so actually that is my journey from Silicon Valley to the world. I'm a medical doctor in Taiwan, and I was sent to Silicon Valley to learn how to start up a company. And then with my partners, we go back to Taiwan and start up iXensor. And right now we are doing doing the business all around the world. And I also start up another company. So I think these are our milestones. So I think these are my introduction of the company. So if you have any questions, I'm ready to answer. Thank you very much. Hello.
Thank you, sir. Thank you, Mr. Jerry. It was great inputs. Wonderful talk. I request the participants to ask the queries if they have. It's a question answer session now. If they have some queries, they can write in the chat box or directly ask those. Yes. Sir, I have a question with reference to the innovation, particularly how much is the duration right from conceptualization to the product launch in the market based on the invention and innovation? Yeah.
I think for time, from concept to product, actually it can be very fast and very short. For example, it takes about 5 years to develop the technique. However, after we develop the technique, we can finish the little small robot in 3 months. So it can be very. I think the most important thing is that you have a concept. Actually, the first thing is not doing the prototype. actually it will waste your time. So for me, I think the first thing is that you have to check the several things. First is the IP possibility. If the business can be protected by IP within a business. Second thing, you have to make sure the market is big enough. So if the market is not big enough, the VC won't invest you. So and then technique as the technique possibility. Sometimes we will think that it's not too easy. You have to really follow what you have and what you can do. So I think don't go directly jump into the market too fast. Think and planning is very important.
Thank you, sir. Thank you very much. Audience, if there is any question, you can toss the question.
Good afternoon, there. Good afternoon, Jerry. I have a question. With the pandemic going on in India or like other countries, we all know that we have a healthcare system that is not very effective. So how your company plans to apply the your company, what is your plan of your companies in India?
Oh well, right now we are looking for, because right now we are looking for partners all around the world. Actually, we have the during the pandemic, almost all the governments all around the world have a process called EUA, the Emergency Use Authorization. So we have already got the approval for EUA in Taiwan, and we are right now apply for EUA in United States and in Europe. So for India, if any of you are interested about this part, you can also help us. We will help our partners in India to go through the process of EUA in India or other area, so they can sell over there. So I think the most important thing is that if the team or if any one of you want to import this device to help medical doctors in India, you have to be very familiar with the FDA in your country to go through the process. However, I think that is not difficult. Actually, we already have the experience in Taiwan.
Okay, thank you.
Thank you, sir. Thank you very much. Organizing team, please go for the summarization of the session. Organizing team. Ronald. Shivani.
Yes,
Maya.
sir. Yes, sir. Thank you, sir, for your wonderful session. It was really great to have you today with us. Your knowledge was about the medical field is really inspiring, and examples stated by you in the session regarding the technology and invention was really great. You have also cleared the doubt overall in the session, and it was a really good session and brainstorming one. Thank you, sir.
Rane sir?
Thank you, sir. Yes, sir. बोलिए sir.
Actually, I want to ask a question from Jerry.
Yes, sir. Yes, बोलिए.
Sir, how much time it takes to grant a patent in Taiwan?
Excuse me, can you repeat your question again?
Sir, how much time it takes for you to grant a patent in Taiwan? A patent application in Taiwan, how much time? And what are the basic issues raised by the patent office for your response to be submitted, that what are the major objections before granting the patent?
Well, for patent, of course, the most of the patent we already apply for that part, and in the last 5 years, we already have 20 patents granted. And for the NSR, such that you mentioned how long we take to be granted for the robots in by TFDA, Taiwan FDA, it takes about 3 months for the approval of Taiwan FDA for the nasal swab robots. And I think is not very fast, but fast enough, because during the pandemic, actually most of the government have a very similar pathway. So if in India, I think they have also the pathway, so we can go through that part. Yeah.
Thank you, sir. Thank you so much. Is there any other question? Okay. So we will close the session. Thank you so much for joining with us. And we hope same kind of cooperation and the necessary support will be available from you in future also. Thank you, sir.
You're welcome. Thank you.
Thank you. Bye. Bye.
Bye.
Organizing team, right now we have another 10 minutes. So we will wait for the speaker to join. Participants, they can wait for the next 10 minutes by the time the speaker will join, and then we will start the next session at 3:30. Thanks for your patience.
Hello. Hello.
Good afternoon to all, and I welcome you all for this session. And the topic for today's session is Journey of Research by Jaya Sagar ma'am. She is a PhD scholar at University of Bristol. She is
Good
the
afternoon,
youngest
madam.
national.
Yeah.
So can I continue?
Yes, please continue.
She is the youngest National Youth Awardee in India for research and innovation. She has done a significant contribution in the international science and engineering field at 2014 held at Los Angeles. She has worked extensively in the fields of apple farming, renewable energy, Indian defense 5G communication systems, and quantum computer. She is an electronics and communication engineer from NIT Hamirpur batch 2020 and currently enrolled as a PhD scholar in quantum engineering Tucci Smith Scholarship at University of Bristol, United Kingdom. She is also running an NGO for promotion of girls in the field of science and mentored 5,000 plus students in Himachal Pradesh so far. Ma'am, I request you to continue with your session.
Thank you very much for this lovely introduction. A very warm good afternoon to all of you. Thank you so much, Dr. to please invite me here with the opportunity to talk to all the students. I'm really sorry for the delay because I had an unstable internet connection. Oh, I get a message in the chat. Is it better now or? Hello, is it better now?
Okay. Yes, madam, please continue.
Yeah. Thank you very much, sir, for inviting me here. I'm really happy, and I'm so sorry for the delay. As I mentioned, that there was some unstable internet connection. I could not get in, and yeah. So now we are here, and we'll start with my journey of research. I hope all of you, during your studies, whenever you get involved in your studies, you feel like this is what you want to do for the rest of your life. And that is when you feel that you want to be a researcher, you want to get into either academia or you want to get into uh, research. So today we'll just take a small glimpse of how it all happened to me. And also we'll discuss some few projects that I have completed during this course. So all of these projects that I have done, think of them as basic projects done by a schoolgirl or an engineering student. And you would feel that all of these things were somewhere in the back of your mind. If you guys are comfortable with Hindi, then I would say ये सभी चीजें आप लोगों ने किसी ना किसी टाइम पे सोची होंगी कि इस तरीके से की जा सकती है, लेकिन maybe you didn't take that step that was required at that moment. So now we'll go through the presentation, and all the projects I'll talk about, it's not me who will talk about them, it will be you who will talk about them, and we'll see like how much can you figure the brain and thinking process of let's say a 15 or a 16-year-old girl, right? So let's I'll start presenting now. Okay, so this just give me a moment. Yeah, so yeah, is it Is it easily visible to everyone? Can I just get a confirmation that you can see my screen?
Yes, madam. Yes.
Thank you very much, sir. So, yeah, once again, thank you for having me here. I am currently enrolled as a PhD student at University of Bristol. It is one of the best universities in the world that are working in the field of quantum physics, because since it is a very expensive field, because you know, all the equipments and instruments that we need for the experimentation of quantum physics, they are quite advanced, and they have to be quite robust, and they have to be you know, they're kind of very expensive. Even like for the first few months, the basic crystals that we were working on were like worth millions of pounds. So not many universities have this field, and that is why I had to make a shift and come to UK for my higher studies. And yeah, so that pretty much explained things, that I wanted to work on the subject, and there are not many universities in the world doing this. So I took a leap and I came here, and I applied for this particular course, that is a direct PhD program direct after your BTech, online. So last year I did an internship from Austria, and I worked on quantum technologies, the quantum computing. Basically, we'll talk about that project in the later slides. And my professor, being so happy with the work that I did during my internship, he recommended me for this direct PhD program, and I applied for this online. I filled a SOP and the letter of recommendation from him, and a few more things, and went through various interview processes. And here I am, the only Asian in our cohort, and all the expenses are borne by the Zuchi Smith Scholarship, which is a scholarship by a scientist, the legacy of a scientist, that all of us deem to be. So let's talk a bit about my subject first, because that is what I love. So, how is quantum physics or quantum computing or quantum technology is different from the regular ones? Now, all of you budding engineers definitely know that the basic computing, or the classical computing, I would call it, works on bits, 0 and 1. Everything you code onto your computer finally get converts into machine code, and then it gets converted into zeros and ones and is fed to the machine. But quantum computing or quantum technologies is a bit different, because when we talk about um, atoms, or we talk about photons, or any superconducting qubits, or any other platforms, they are not just zeros and ones. They are basically the superpositions of zeros and ones. Now, what does a superposition mean? Superposition means that they are a mixture of both the states. So if you have a qubit, all of us have studied about the Schrodinger's cat. So this was the scientist who put a bowl of poison and a cat in a box, and then he was too afraid. Okay, well, we'll go there. But he said that when the poison and the cat, they are inside the box, he does not know if the cat is alive or dead until and unless he makes a measurement, until and unless he, you know, lifts up the box and sees what's, if the cat inside is alive or dead. So this is what it is, that in quantum physics we deal with a state where the box is closed. Later, he was too afraid to find out if the cat is alive or dead, that it is said that he didn't even open the box. So, and maybe the cat died then there. But inside the box, you don't know what is the situation of the cat, of the Schrodinger's cat. So that is the quantum state where it is in a superposition. It could be alive, it could be dead, or it could be somewhere in between, about to die. So this is what is like a superposition. So we will talk about a superposition a bit more, because we have a famous lock and key example for superpositions, that if for a regular classical computer you have to open a lock using the regular classical computer, and it says that okay, like the answer is like the key is a 10-bit sequence. So what a classical computer will do, a classical computer will go like it will, it will make attempt 1, attempt 2, attempt 3, and it will keep on making attempts like 00000000001 0000011 0000011, and then 1000, and all those possible combinations, and then would finally manage to open the lock. So it will have to take almost 2 raised to power 10 attempts to open the lock at max. Whereas in quantum computing, the lock is opened by just first attempt, because all the bits they go in a superposition, and they can be 0, they can be 1, whatever fits in. So it fits in, and then the lock's open. So which kind of states that it would be very fast when we exceed the limits of classical computing. We say that we have achieved quantum supremacy. In that regime, no classical computer can beat you, and that is something in the probabilistic approaches, right? So if you give a question of, let's say, 2 plus 3 to a classical computer, you will get an answer really quick. If you give the same question, 2 plus 3, to a quantum computer, it might take months, because it is not very good for deterministic approaches. When you know what the exact answer is, then your quantum computer might not surprise you. But if you don't know what the answer is, and if you're looking for something probabilistic, that's when you need the quantum computers. So don't expect maybe in future, in 50 years, you'll have a wristwatch with a quantum computer, or you'll have a phone with a quantum computing. No, that won't happen, because number one, it requires temperature that is almost absolute zero, so millikelvins, right? And it is not really good with deterministic approaches. So it is very useful for quantum cryptography and quantum key distribution, and that is something now I will be focusing on my PhD, which is quantum key distribution through satellite communication. And we want to develop uh, like make sure that information travels really safe and the fastest possible. So yeah, we'll get into it later. So getting to here, when this was all over the news that I bagged the scholarship, and I'm coming here doing my research in the UK, and I'm working on a field that is so difficult, I would say, like as people consider it. So how did it all happen? So I guess pretty much all of us know how things happen. Things happen only when we give efforts into them. If you want to make something happen, if it is studies, then you have to study, right? So there's no way through success. You have to work hard to um, get the things. And uh, okay, enough of studying, and a little progress every day adds up to big results. So you have to stay motivated and study, and put your efforts in every day. And yeah, it adds up to big results. So from books to your labs, everything matters. All the different assignments and different things you do, they all matter. So not just the studies, because beyond studies, like with the regular matriculation and 10 plus 2 and BTech, and some the regular courses, the other things also, the co-curriculars or different skills that you acquire over time, they also add up to it. So I enjoy snow skiing. I've been a national player of snow skiing, and I have worked on basic water sports. I am a trained classical singer, and I can also play harmonium and tabla. And yeah, I've also learned karate for a few years. So yeah, like most of us learn karate of self-defense. So yeah, I did it with this institute, the World Karate Foundation, and got a grade for it. So I'm basically a blue belt. And if you would have a look at my marks or my divisions, you would realize that many of you have better marks than me. Many of you were better at studies than me. Then you of course can do a lot better than me, and maybe we'll just have a look around it. So my journey with science began when I was a little kid back in 2019, and I went for the state level children science congress quiz. So it started with like subdivisional level, like block level, subdivisional level, district level, and then state level. And I started with science quiz, like the science quiz competitions in the school. And then I realized that I don't want to just memorize everything and test my memory every time. I wanted to do something in depth. I wanted to study about things in depth. And then I started to work on my hydropower project's scientific report. And then I worked a bit more on it for like, let's say 2 years. And then I made an eco-friendly kiln using like the basic phenomena of our NCRT books from class 12th or so. So, and then I again switched to hydropower projects because I belong to Manali, and all of you must have heard of Manali. It's a beautiful town in the northern India, Himachal Pradesh, district Kullu, and we are blessed with a very fast flowing River Beas, which starts at Manali and then goes to meets Satluj, goes to Pakistan, and then gets to the Arabian Sea. So River Beas is there. So because of the very fast flowing river, there are so many very different hydropower projects. And hydropower projects, they might be the cleanest source of energy that we think, but they have a lot of climatic challenges that they are posing to people and the area around. So I worked on them. We'll talk about them a bit later. And then during the National Level Children's Science Congress, we had quiz competition on nuclear physics by Baba Atomic Research Center, and that was the first time I visited Mumbai or Maharashtra as such, because we went to Baba Atomic Research Center for 5 days, and that was pretty much the motivation. And I was like, I wanted to be someone like the scientists we were seeing there. I wanted to work, do something that important to the nation, that people who are coming to see us will have to go through security checks, like, as you know, in the area of Anushakti Nagar, we realized. And it was just, even while going to Trombe, you have to go through a lot of checks and security things. And that was, I was like, oh wow, this is something I want to do for the rest of my life. And so that kind of was shaped my future. And I went for Inspire Science Camp in 2013, and then Iris National Fair, which was a national fair held at Bangalore. And that time I was working on my project report on apple farming. So Manali is famous for tourism as well as its apples, and my family being involved in apple production, so we were pretty involved in horticulture, like most of us. So I just thought of improving apple farming. We'll talk about the project. And this project took me to Intel International Science and Engineering Fair in 2014, which was held at Los Angeles in US. And out of 1,800 participants from 80 different countries, I bagged 2 prizes for India, the Grand Award and the AVSC Special Award for Innovation and Creativity. And we also got to meet some Nobel laureates, Dr. Frances Allward, the Nobel laureate for chemistry, and that woman inspired me to, I just saw that, okay, Nobel laureates as well are real human beings. They're nothing different from us. And I was like, okay, cool. Now this was kind of assured that, okay, this is what I want to do. I want to become a scientist. So now let's walk you through my different projects. So this is a nano hydropower project that I worked on. I did it as a kid, and then later, when during my college, I realized, okay, this is how you publish research papers. I got it published. So let's just talk a bit about it. So I'll walk you through the problem that, okay, so there is this hydropower project. This is like the Google map. Can you see my pointer? Um, can you see my pointer? The arrow. Okay, all right. I'll assume you don't. So okay, so there is this hydropower project that takes up the water from the river, and it takes it to the power station where, like, it is taken through a penstock, and then it like rotates the turbines, and then you get electricity, and the water is then back thrown into the river, and the water is like same, it does not lose anything, right? So but that gap from where the water was sucked up from the river to the point where it goes back into the river, all that stretch of the river was dried. So when this stretch was dried, it really affected the water table of the area, because there used to be a lot of water, but now there was no water there, and the trees nearby, they were like, they were dying and everything. And then later, when it was a cloud burst near that area, the hydropower project, they just stopped their gates, and they just stopped, taking the water into their penstock, and all that water went straight into that stretch, which was like dry for years now. And that stretch, because, like, it was dry for years, so there were so many people who encroached that area, started living there, thinking of, there's no water here. And when it was a cloudburst, and then it was flooded, and people lost their lives, and people lost their property, and it was pretty disastrous. So we were just thinking about it, and as kids we realized, oh, okay, this is a bad thing. If the hydropower project would have not been there, there would have not been any flood. Like, if a cloud burst, then it would have just gone its way, because of the of that stretch being dry for a long time. It was being a problem. So we developed a survey for the people living there, that what um, do you think, like, the destruction is worth the generation of 9 megawatt of energy, and some questions like that, so that we, it was a social report, basically. And then we also talked about the solution. Okay, I don't have the solution, the picture of it here, but we designed a solution. It was called a nano hydropower project, which could be directly implemented on the small water streams. It would not stop the flow of the river, but we'll just have to, make some thing like stairs on the river, and then we could use like the small long turbines for getting some energy. It won't be as much as 9 megawatt, of course, but we could have so many such small nano hydropower projects on the river without changing the course of the river. And that is how we were trying to work for it. So, and then my project that took me to the international grounds was mustard flowers to attract pollinators for better apple crop. So the quantity and the quality of the crop, especially the fruits, it depends on the pollination that's happening in the trees, right? So the flowering period of apple in our area is March, April. So if you plan to go to Manali, March end or April is the best time, because it's all flowering and blossoming. There is a cherry blossom, there is an apple blossom, and also you would see a lot of mustard being planted there. So mustard has yellow little flowers in a shape that is very attractive for the insects, and yellow is the favorite color of honeybees. So just coupling things up, we thought yellow is the favorite color of honeybees. Honeybees are always attracted to mustard, whereas apple has whitish, pinkish flowers, not very attractive for honeybees for some reason. So, what we used to do to increase pollination, we used to make bouquets, flower bouquets, small flower bouquets, and hang them on the apple trees so that the honeybees are attracted and then everything, and it was a tedious task. We even had to miss our schools and go and do that. So what I thought was yellow is the favorite color of honeybees and they love going to mustard. So why not plant mustard in an apple orchard? It would attract the honeybees to the apple orchard. And any insect, when it takes the nectar from a flower, it tends to fly upwards. And when it would fly upwards, there would be apple. So it will pollinate apple because it's food after all, if not its favorite food. So I conducted this experiment. So it's like we planted mustard in different patterns in an apple orchard, and we compared the results and a bit of discussions about the quality of apple produce. And then we realized that if we plant mustard and in the circumference of the towel of the apple tree, not a lot of mustard, just a little of mustard, it would be the best. So this was that project. I also got copyrights for this project from Government of India, and I was the youngest one to get it. And that is how I got to know about the IPR policies of the country, because I thought I would get a patent for my project. But then when I applied for it and I got to know, oh no, this is not something that is sellable, it's just an idea. Anyone can use it. So I cannot get a patent for it, but copyrights for my work. And then I worked on this another project. So in the engineering first year, I guess we read about the piezoelectric materials, right? And when I learned about piezoelectric materials, I wanted to use them everywhere, but because they were so interesting. I thought, you just put pressure on something and it generates electricity. Like, wow, it is the best material ever. It is the solution to all the problems. So we read about the piezoelectric shoes that generate electricity when you walk on them and blah blah blah. So I thought, okay, why not? So in the hilly areas, usually what happens is when it starts raining, uh, we have problems like landslides, and then sometimes in the landslides, the electricity poles and wires, they are kind of uh, they're damaged and everything. So um what happens is usually the electricity department, when it's raining heavily, they turn off this electricity supply from their end, so that even if the electric poles they went into the landslide or something, it would not cause much of a problem. But it causes a problem to us because we don't get any electricity. So I thought of using this. So earlier I thought, okay, let's make the roof of the houses with piezoelectric material, so whenever the rain would fall on them, there would be electricity. But then I realized that that's a lot of piezoelectric material, and piezoelectric material could be expensive. So there's no point of making the complete like the surface of the thing with the piezoelectric material. So I realized, okay, so from the drain pipe where the water collected um, in the roof is thrown down to ground, and let's say your house is 2 stories or 3 stories, wherever it would fall, we can have a piezoelectric material there, a stabilizer, battery, and power supply, right? We'll get it. So we tried to work it out, and it kind of worked out really well. We used this drain pipe, and then we used a piezoelectric plate. So the piezoelectric plate that we made was made up of little piezoelectric coins. So that was not very efficient, but if we had like a big this big piezoelectric plate, that would have worked really good, we hope. So yeah, because according to the maths we do for piezoelectric materials, we can harness some good energy out of the rain using a piezoelectric sheet, right? So all of you must have studied about all of this, and this would look pretty simple to you. But now, like, let's say things were kind of improving, and my science was kind of improving. But there was this one thing that whatever I learned, I tried to implement it and use it for the solution of various problems. So then when we all study about IoT and everything, I started to work on this project about smart solar air heater. So in towns like Manali, in like the cold areas, even if it is sunny outside, the temperature is like 1 degrees or 2 degrees, or even if it's like the brightest of the sun you have ever seen, but it would still be very cold inside the rooms. In the sun it's fine, but if you're in the shade it's freezing. So we thought of doing this for schools, especially because they are usually in the day and it's sunny outside but not in their class. So we thought of using this smart solar air heater. What it would do is, it is just like the solar water heater, but it's for a different fluid, that is air. So we have to have like a different wire mesh for heating it up, because it's not as easy as water, because it does not have a specific heat capacity required. So we worked on airflow simulation for this, so that we can heat up rooms with the solar energy without converting it to electricity. And then I worked on this project, Avalanche Rescue Belt, for which I have also applied a patent for. So what happens is, when you go trekking, or when you go climbing the mountains, it's snowing and you don't know what the weather is going to be, and you like, oh, it's just snow, it's beautiful, but it's not. It's deadly. You go there, you get stuck in the mountains because of the snow. You cannot find your ways. There are whiteouts, there are avalanches, and you're trapped in an avalanche, and you are, let's say, 8 or 10 feet down under the snow, and nobody knows where you are in the mountains. And that is something we come across every now and then, because so many tourists, especially youngsters like us, they think that they can do anything in the world, and they don't need to take care any weather predictions into account. Nothing is too risky for them, and they just think of themselves as maybe some heroes and heroines from the movies, and they think everything will have a happy ending. But that's not what happens always. So this project was inspired by two of my seniors. They were doing the MTech when I was doing my BTech, and they went for a trek to Shikari Devi. There is this area in nearby, since NIT Hamirpur was in Himachal only. So, in the Himalayan area, they went for this trek in the winters, let's say in February, January end, I would say. And it was snowing really bad when they were there, and they got struck, and they could never come back. And when their bodies were found, they were mutilated by dogs and wolves of the area. Like, obviously they were half eaten, and which was very disheartening. Like, that was very, very bad. And that's how we came up with this project, that okay, if you're trapped in the snow, what do you need? You need to have a quick rescue, so that you can be saved if there is a chance. Number two, your dead body should be recovered as soon as possible. Number three, you should be saved from the wild animals, even if you're dead or you're alive, right? Because if it's a dog coming and eating you, you're stuck in the snow, you got no chance. That's a painful death. So we worked on this project where we designed a belt that could still I have applied for the patents, not going in the details, but it can provide you safety from the wild animals, because it emits the frequencies that are kind of uh, the kind of a bit torturous, not very torturous, we would say, but not very pleasant. So very unpleasant frequencies for the wild animals. And we checked it under snow. These frequencies, they travel through snow, because many frequencies, they don't travel through snow. They can travel through water, but they cannot travel through snow. So we realized such things, and we used some particular frequencies, and it was a basic Arduino model in the end, right? So with some things in proper calibrations, we did this project, and this was also like recommended by the recipient of the National Adventure Award and Everester. So Mr. Rajiv Sharma, he has climbed Mount Everest back in 1990s. He was one of the the early Indians to scale Mount Everest. So yeah, he also said that our project was really useful and can help. It was very secure for the mountaineers, and let's see how it goes. And then finally, I would start talking a bit of more science. So I'll talk about my first internship in quantum computing. So quantum computing, as we know that it requires a very low temperature, let's say sub-zeros, that to millikelvin. So it's like almost minus 273 degrees Celsius in Kelvin, 0 Kelvin, right? So we required a temperature that cold, and that is very difficult to achieve, right? Even if you have a chip of this size, you need almost the freezer, or let's say the cooling system of almost of a size of a building. So that is why if we have to make a quantum computer or some circuits, they should be smallest possible, because as you will increase the size of the chip of your quantum chip, that would increase like the size of the system required to cool it down, right? So there was this project that was the faster manipulation of large quantum integrated circuits using wire recycling, just to keep the size of the chip smaller. We had faster manipulations of like integrated circuits, and we used recycled the wires so that the same setup can do a lot more. And this project, like the idea was of course Dr. Parler's, and he wrote a research paper on it, and then I did the Python implementation of his research paper and drew the software that how will we recycle the wires. So this software was made on Python classical computers. It just wanted to to show that how the chip should be recycling the wires, and we can ease our we can increase the efficiency of our quantum simulator. So this was my project, and he was really happy with the performance. I got 98% for my intern, and while coming back, he also gifted me some chocolates and the letter of recommendation. And then I did my second internship, which was a remote internship, and I did it with Nokia Bell Labs, US. And my supervisor was from University of Bologna, Italy. And I'm still in contact with him, and he's still now he is working with Nokia in Denmark and Aalborg. So it was a wonderful time knowing so many I was working on different projects during my BTech, and when I started working under him for machine learning methodology for optical communication systems, and I was an electronics and communication engineer, so it was working really well. It was a remote internship, so he would send me the papers and then the work that I need to do, and I would just read the papers, ask my doubts, and then try to find out the code for the ML, what I want to do, drawing comparisons, sending him results, and it was really good 3 months. So what were we trying to do was, when you have an optical communication system, so like you're sending information, it is going through a channel and then it is received. So in the channel, it will get some noise, different types of noise, right? So what our idea is, we will compute the noise in the channel, and then we will distort our signal before sending it in a way that it will compensate for the noise, will compensate for it. So let's say the noise dips it down or changes its phase by, let's say, 15 degrees. So we'll distort our signal by 15 degrees initially, so that the noise would reverse it back to the actual. So that is how, this is the pre-distorter that we wanted to make, and we figured it out, and we tried using different machine learning algorithms for it, and it worked out well. And then for my minor project of my BTech, I worked on system for management of the EM battle space, and that was something that could be used in Indian defense. And so talking about this project, it was a web-based system for dynamic allocation of frequency bands for various weapons, radars, or defense services. So what that happens is, let's say you're in a battlefield, there comes a missile, right? And if you know the frequency of that, the operation of that missile, you can block the frequency of in that area for that, and then the missile could not communicate with the ground station, and then you can just change its way, and a lot of things can be done. Some missiles are just they are pre routed, that this is the route they'll follow, and they don't need any communication later with the ground station, but they're just fired. But there are some advanced missiles which stay in communication with the ground station, and they are very, very, very risky, right? Because they can always change their targets. So if we have such missiles and are very friendly neighbors, let's say we are in a war with them, and then they block that frequency, and then they use their system to control our missiles, and maybe our missile is coming back to kill us. So to avoid such situations, it was a problem posed by DRDO, that they wanted a system for dynamic allocation of frequencies for various weapons, not just missiles. Missiles is just a version of it. Okay, let's say it's risky and all of us can relate to it, but different radars and different systems like tanks and everything, so that we can allot them different frequencies uh, in real time, so that you never know what frequencies are they working on. So it's very difficult to try to hack them, right? Because you don't know what frequencies are they working on. So this was we did this dynamic allocation. So now this dynamic allocation depends on various factors about the type of the um, the type of the it's a radar or it's a weapon, and is it on the land, is it on the air, is it under the water, right? So we have various communication models. So there are some frequencies among which we can use, and there are some frequencies that we cannot use, and so we tried to figure it out, and then we made a model of it on Django Python. Now, for my major project, I worked on a software-defined radio using the NIUSR radio to improve some talk schemes and license assistant access. So when we try to use LTE, the regular calling that we do, long-term evaluation over unlicensed spectrum, then we have a coexistence system, and I worked on my major project to improve it, so that we can communicate. Usually what happens is, when at a space, let's say in a railway station, or before the COVID days, in a football match or somewhere in a stadium, there are so many people, and all of them are trying to put their Insta stories, Facebook stories, and uploading pictures, sending messages, or trying to call people, right? So in such a situation, the nearest tower there, nearest antenna, it has a lot of pressure on it, and that pressure could result in either you'll have slow internet, or you won't be able to connect to your call and everything. So we used cognitive radio designs is that will use the unlicensed spectrum, like my phone will use your phone as antenna, and that's it if the actual antenna is really busy. So that is like the overview of things that were happening. There is a lot to go in detail, but I won't get into like such real details of the project, but I'll give you a gist of it, that we tried to improve the performance of a communication system, and when there are a lot of users, right? So there were problems, like there were slot jamming effects, there were slot tracking errors and things. So there is this technique called the listen before talk technique. So if you are not using your phone much, right, so I can maybe send my information between the slots, like between the gaps in your information. And it was, yeah, it was something like that, for which we made this algorithm, and then we did a spectrum energy detection. And then after detecting where we can send our information in between, so it's like tightly packing the total information, right? So all of these projects, they led me to different places, and the best was on 12th January 2018. I was awarded with the highest youth civilian honor in India, that is the National Youth Award, and I got it for research and innovation. And also, I received in 2019, I received the National Women Achievers Award to promote science as a career for girls. And through this NGO called Mangal Dayak, I took the word Mangal Dayak from our national anthem. And if you would remember, it's almost in the end of the national anthem, where it says Mangal Dayak Jaya He Bharat Bhagya Vidhata, right? So from there, I loved this word. Like, I am a good singer, but not right now. And I picked that word from there because I love the word, and that's how my NGO started. And till now, we have talked to more than 5,500 students all over Himachal, promoting them to take up science as their career, helping them with their basic concepts of science. Because all of us, we don't, sometimes we just hate a subject because we don't understand it. And I guess physics is that one subject that many people in school, especially girls, they hate it because, it's just trend. They don't even try to understand it. They're like, oh, it's physics, we hate it, right? It's maths, we hate it for absolutely no reason. It's just maybe because you don't understand it, or maybe you don't try to understand it. So we took the basic concepts of maths and physics to the students, and we tried to encourage them to get into science as their career options. And I would say the best day of my life was when I shared the stage with Dr. APJ Abdul Kalam as a keynote speaker at the launch of Rashtriya Avishkar Abhiyan. And that was literally the best day of my life, where we talked to more than 3,000 students altogether in Talkatora Stadium. It was back in 2015, and 19 days before the demise of Dr. Kalam. But it was a wonderful meeting, and yeah, it was a lovely talk. And also, I have received the JRPD Memorial Award for Excellence in Science and Education back in 2013. So these were a few of my notable achievements. And talking a bit more about my NGO Mangal Dayak. Mangal Dayak is an NGO for promotion of girls in the field of science, and we also help them with. So when I started working with girls and promoting them towards science, I realized that girls are intelligent, but they just choose to take up the trends that's happening. Let's say, usually when they see their seniors, and the girl, like, their senior girls are like, oh, we don't like physics. Or sometimes teachers also make that impression that girls won't understand physics and maths, whereas boys would, right? So they just keep it like, okay, I'm a girl, I don't understand physics. I'm a girl, I don't understand maths. But that's not how it works. I'm a girl, I'm studying quantum physics. It's a hell lot of maths and physics, and I understand it. Because if you just give it a shot, you understand it. It is rocket science, but we can understand rocket science. So yeah. So this is what we realized, and we realized that like the concepts, the studies, the opportunities, and a lot of factors affect um, girls when they're growing up. So we took up their career guidance, and also in the rural areas we did workshops on their hygiene, and we did various workshops, as you can see on the screen, that in various schools we um, we took different types of workshops. We inspired them to innovate, work on various projects. If they have any ideas, how can they how can they take their ideas and shape them well into something that can be presented on various platforms, right, on for various science competitions and everything. So we did quite all of these things during the time I was back in India. And then 2020 happened and it was COVID, and then I got here to UK. And I'm still hoping that I'll be able to so here till now, if I talk about the few months that I've spent here, I have been working on some the projects that we had to. We are studying some subjects because I did not do my masters, so I have some courses from masters that I have to take up. So I'm like taking up more than almost 8 to 10 subjects at this time, which is quite tedious, I would say. And I think I'm going to fail one of them because it is in all studying so many subjects. I could not focus like in all of them. I don't know. I have my exams from Monday, so we'll see. But I'll try my best. But it is kind of being difficult, and there are so many things that are different from India. Like definitely, because back in India, when we have some doubts, we don't understand anything, we can talk to our teacher in our mother tongue, and you can talk to them in Hindi, or maybe sometimes, you could talk to them maybe in your mother tongue, let's say Marathi or Bengali or whatever, and you can understand the concepts really well. But being here, it's not just a different language, it's also a different accent. So yeah, like picking up a completely different accent is, it's kind of difficult, and you just don't number one, you're not understanding it, and number two, you don't get the accent, number three, you cannot even ask them the doubt in your mother tongue, and you don't know how to translate your doubt in English. And that kind of is just it just gets to your nerves at times. But it's wonderful. It is a great learning exposure. I feel that in an year of engineering, I don't learn as much as I learned in just um, 2 months or 3 months that I have been studying here, because there's a lot of experimentation. So of course, like, we have PhD students, but they just, when we came and they were like, okay, you have to do a team project. So you're 5 people, go into the lab, take a time of, let's say, 3 months, and do this project, prove this in the lab using the optical instruments. And we were like, okay, and they were like, choose, like, just tell us what optical instruments would you need. And we gave them the optical instruments that we would need, and they got all the optical instruments to us, and they said, okay, now do it. And those crystals were worth um like worth crores, right, that we were just using. They were more expensive than diamonds, and we were using those crystals for our experiments, which was absolutely amazing and thrilling. And I feel that was something that gave me a rush, that whoa, I am an experimental physicist now. And so now for my PhD, totally I'm shifting to quantum key distribution and cryptography, and I'll be working on satellite QKD, the ground station of the satellites. And for our pointing towards the satellite, we'll also get access to some of the observatories back in India, let's say the Ladakh Observatory and all. So I'm really excited to, sit here in UK and getting an access to the telescopes there in India and actually controlling them the way I want to. It will be fun, and I'm really looking forward to it. And yeah, I guess that's all I had in my talk for you. And I appreciate that you all for your time and your patience and bearing with all of this. And feel free to ask if you have any questions.
Thank you, madam. Thank you so much for a wonderful session. Now, audience,
Thank you
if you
so
have
much.
any questions, you can ask.
I know it's a lot of information for a small time, and you guys must be digesting it. But if there's anything you feel like asking, maybe with your, if you're planning for your higher studies, or you got any doubts with the projects, or how to take things up during COVID, or anything, feel free.
Madam, just try to differentiate between the research culture, what you have experienced in India and what you are experiencing in UK. What is the basic difference between these two?
Oh, that's really wonderful, sir, because there is a very big difference, I would say. Um, so back in India, maybe because I was doing my um, bachelor's, so of course we did not have access to a lot of labs or the research culture as such. But even our seniors, like the students, would spend a lot of time trying to read things for the instruments that they want in their research, and then waiting for the year, and then ending up doing a PhD without even their instruments coming in. And the instruments would come in, and supposed to work at the end, and now they're like, oh, we are out of time, and this cannot be done, right? So and this is one of the things that I feel is different in hair, because if you need if you think you need something, that thing is made available to you really quick comparatively, so that you can work with the right enthusiasm. Also, the I think here in UK, parents cannot force their children to study. So parents have no control over the children after they are 14 plus, right? So the people who are into research or who are into academics, it's not because they are forced to do it. Whereas in India, most of us are, forced by our families that you have to be an engineer, you have to be a doctor, you have to get into research, you have to do a MTech, you have to do this, you have to do that. Whereas in here, I think most of the students, they're studying because they want to study, and the universities for them is not, it's like they don't even have to pay a hefty amount for their studies, so they study willingly, and they take care of the things, like like five of our students, we worked in a lab for 3 months, and we did not break, like, even accidentally, we did not break any single thing in there. But whereas in India, if you think of letting five students go into the lab on their own without any supervision or cameras, you would think that okay, now you'll get some news of things getting broken. But I think that we consider, when we are here, and the culture here is very um collaborative. It's not just like the supervisor telling you what to do. It is more like, okay, let's do it together, which is exactly the culture that we require for research. And yeah, that is one thing that I really appreciate being here. And yeah, otherwise, like, India is doing wonderful in research, and I hope I will be able to come back to India and maybe serve in DRDO or ISRO or anyhow to the nation. But let's see how things turn out. I have still 4 years to complete my PhD and think further. Yeah.
Thank you, madam. Thank you so much. Audience, if you have any questions, you can ask. Organizing team, if you have any question, you can ask. Okay. Thank you, madam, for joining us and enlightening the audience. Thanks once again. And in future also, we expect such kind of a wonderful association with you. Thanks. Bye bye. Great time.
Thank you so much, sir.